Snore form again, because it's a fun word to say. Do you have questions while this thing boots up for 8 minutes? Or would like to chat?
What's your favorite movie?
My favorite movie? So glad you asked that. I've wanted to talk about that all day. It is Tremors. I am an obvious troll. Who is obvious? No, I don't know.
Sure you didn't like Land from Outer Space? That movie was pretty good.
It was pretty good. You know, I'd say second best though. Not even heard of that. I feel like I should be repeating these movies back into the mic for the online students to hear. So they can be like, wow, you guys really do look like awful movies. Wow, this is awesome.
What's your favorite project for being a CS major?
My favorite one in a morbid way was my first year, my second quarter over in California. We don't believe in semesters. I made a Crazy Eights game with like a CC Windows or something. So it was a C library. And it looked very nice. You know, you'd have like, I want to draw it on the board because this is awesome. You'd have like a deck here. It was a little rectangle that had a D on it. There was like a pile here, you know, and it would have like a 1 and a little heart or something that I drew and with pixels. Anyway, and then you'd have your hand down here, you know, your 8 cards, and you'd see your opponent's 8 cards. And everything was beautiful upon startup. And then you'd click here to draw a card, and a card would appear over here, and half of your hand would disappear, and the other hand, or the other half, would flip upside down, and this guy would change into an 8 for no reason. So, anyway, I'm awful at this. I actually never got better. So, if you were hoping that I'd help you with your assignments, you're going to be severely disappointed. All right. So, who remembers Bacchus-Noriform? Big yays? 1. All right, cool. I guess that means that this is going to be fun. Conflicts. Okay, so I made a awesome grammar for us to look at together and be happy. But I don't want it to be conflict. I want it to be out. So this is my Lex file. As you may or may not be able to tell, I spent a lot of time and a lot of energy in it. It's pretty simple, but I'll quickly go over it just in case we've forgotten. So our 2 little percents there at the top differentiate between the declarations and the rules. I have 0 declarations, but I do have some rules. There is a C code up there that includes y.tab.h. You should always be including that in your scanner files, and you should be yakking first. If you're not doing that, you're going to get a lot of errors with your tokens. Nothing's going to make sense. So tab.h. I have it returned 1, 2, or 3, and something else. And then I have no C code. Are there any questions on this very complicated lexical analyzer I've created? Awesome. Now, the fun is in the YAK file, I suppose. So that blue text you can't read is standard lib and standard IO. Those are probably going to be in all your YAK files among some other things, maybe string, maybe IO manip or something. So I have 4 tokens, else 1, 2, 3. We just saw those. We hopefully have not forgotten yet. And a starting variable, S. S stands for start. And then I've created 3 other non-terminals, 3 other variables. Uno, dos, and tres. because I'm bilingual, but not really. Anyway, so quickly looking at this on the spot, who can tell me what grammar, what language this will accept? Spanish. Would we like to check Spanish and watch it fail? No. Good answer, but no, I'm afraid not. Yes, I saw you.
Any string that starts with 0 more ones and then has 0 more twos and has 0 more threes.
Very close. Very, very close. Keith.
At least 1, 1,
Mhm.
at least 1, 2, and at least 1, 3.
Yes. So if I was writing this in our regular expression that we're used to with all those dots and pluses and minuses and braces, how would I write this? Good, right? So, yes, Keith.
Does the else at the end of the start symbol, does that mean we have to have some sort of other stuff afterwards?
So I put that in so that I could do everything command line really easily, so that when I press enter, it'll recognize that as the end, rather than thinking that, otherwise I'd have to make files every time.
Got it. It does require something though, doesn't it?
Yes.
So just put a dot at the end of that, we're good.
Perfect.
Oh wait, that's star.
What?
No, it's not.
Right, or a new line.
There should be a backslash.
Huh? Yeah, that's what it is. He needs glasses, very severely, let me tell you. All right.
I think you don't need the bar if you're writing it like that.
That is also true.
No, that bar was the backslash. You just had an extra.
Yeah. I was escaping the escape character. So we've figured out that, which is cool. So I have these rules. I need to see a 1, and then uno is 0 more 1s, right? So by concatenating those, having a 1 and then an uno, it is 1 or more 1s. Same thing goes for dos, 2 dos and 3 tres. Yes?
How come there's no semicolon on the trace, whatever that's called?
The trace rule? It has no semicolon because I'm a negligent programmer, but Yak forgave me because it's the last rule.
My practice actually, it turns out I didn't need any semicolons.
Did you have any ors?
Huh?
Did you have any ors?
Yeah, I think so. I don't remember having any problems.
All right, well, I come from a world of Bison, not Yak, so I don't really...
So it's required in Bison.
It was required in Bison. I would... So... Jesus. I can't tell you with... I love my choices here. Would you like to restart now or go F yourself, sir? Fun times.
Wait, can you put that back up there for a second?
I didn't do anything. It just disappeared. No, I have no idea.
Away?
Yeah. Anyway, quickly back on the semicolons. So it apparently is optional. I'm sorry for lying to everyone. But it's good practice because it makes your grammar more understandable. So I don't know if you guys have ever seen a language that has no semicolons, but it can be frustrating.
Oh, now you can say restart later.
Yes. Anyway, so there goes all the fun of my lecture. And then the action section, which everyone should be somewhat well acquainted with, I just have it printf a little congratulations for us so that we feel good when we've given a successful string. Main doesn't do anything special. It does it calls YY_parse. YY error, just printf so that an error was seen. Obviously, when we do errors for projects in this class, for future ones and for the most recent one, you need some sort of meaningful message. You can't say error seen, otherwise you're going to get like 30%. Even a line number would be nice. If you can be a line number and it messed up on this token, glorious. We'll love you forever. And then YY-wrap is boring. So at the end of it, it returns a like 1 for you've had a successful execution. It's like an error code essentially. So if YY-wrap doesn't get called, it doesn't return 1. You return some other error value. So we yak-d. Does everyone know what -d does? It creates y.tab.h. If you don't do that, you won't have y.tab.h, and you won't be able to link with your Lex file, and you'll be very sad. Does anyone know what -v does? Y.output. Have people looked at that?
Yeah, it was confusing and very, very large.
Good. All right. Because if you looked at it and you were like, it was boring, then I was going to be like, go home. Out.yak. No errors. And we will flex as well. And we'll GCC. And we'll link that in, possibly optional, I think someone said last time. I'll keep doing it. Anyway, so a.out. Someone give me a string to put in. It can be a good one or a bad one, I don't care.
Hello world.
Hello world. Error scene. Huzzah. We'll try 1, 2, 3. Hooray! And then this parser is really only built to take one string. So when I do this again, it's going to cry. But we could have 1, 1, 2, 2, 3, 3, 3. We don't have to have equal numbers, right? Yes, Keith.
If you wanted to make it so it could like do multiple lines, would you just have to have like another rule?
Yes.
That would just recursively look for more of them?
Mm-hmm.
Okay.
Essentially, we'd change our start symbol to be like one or more of these intermediate start symbols, and then the intermediate symbol would be our grammar. Does that make sense? Okay. Probably not, but maybe you guys can. Okay, who wants to tell me what to do? Create a new symbol. What do you want it to be called? Start.
And then change the %start to start.
And what is this? S or start?
Yeah, the other way around.
It's left recursive as well.
So this is a good point, because I lied to you last week, or maybe 2 weeks ago. But I promptly sent out an email apologizing with information you should read about it. Anyway, so it's counterintuitive to me. Maybe it makes sense to everyone else in the world but me. But Yak likes left recursion. The difference is, as we were saying, between these two things, start S and S start. They are semantically equivalent. They mean the same thing, right? And if you're doing this by hand, either one would be perfectly fine. You'd get the exact same things. Your parse tree would look a little different. It would be, skewed to the right or skewed to the left. But it's not even necessarily going to introduce any ambiguity. The only difference is that with this one, Yak's going to cry. It's going to give me a bunch of errors or warnings. With this top one, Yak should be happy. I see lots of confusion.
Isn't the left recursion the second one?
Okay, sure. Then right recursion is the one it likes. I don't want to lie to you again. So I will say A recursion and B recursion. A recursion, this top one, is the one that should work. Yes, Keith?
In his Lex and Yak tutorial ones,
Mm-hmm.
he says that we should be using the second one.
Odd. Because when I run, whenever I've tried the second one, I get errors up the yin yang. When I run the first one, everything's beautiful.
Well, why don't you just show us both so that we can be definitively certain?
Oh, wait a second. When I've done this, I've set it up a little differently.
Uh-huh.
Don't listen to me.
Okay, I'm not going to listen to Keith. because he has requested us not to.
Sorry.
So we're going to take that away. Okay. Oh, on the spec it definitely is. Absolutely, but that's not incorrect, right? The point is that you can translate between a random Bacchus-Nora form spec into a comprehensible YAC input. That's part of translating. Absolutely. Okay, so let's see if we successfully did this, and then we will be so happy. Oh. Now I'm sad. My parser stopped congratulating me. Yes. Sounds like a fantastic idea. I'm just so sad if it doesn't error. Sam, you don't know anything. You found out. I don't even know. Better question would be, how did I get into grad school in the first place? Okay, so it appears to have ran.
Why?
I don't know. This is why I don't do things on the fly. Oh, hey, I'm not in Vim.
Maybe this one wasn't big enough for it to break.
I would say there are like, so we were getting, I don't know how many people read the listserv, but there was, what? We have a couple people who were getting memory exhaustion errors, which is really random, really scary. That's because of this. So our grammar happens to be small enough that it dealt with it. But these are the kinds of things that'll cause your YAC to run out of memory because it's stupid. Anyway, so I'm going to take that out before we look at the y.out because I don't want to deal with it. Yes, Diana?
I have a question on the flex.
I'm excited.
Okay, I'm a little fuzzy on how the parser determines the difference between a number and a dot, because obviously a number is also a dot. So why is there no conflict? It's because it's just linear. the way you write it.
Right.
So it's looking for the biggest one,
But it's also going in precedent. So if it sees a 1, it's going to be like, well, you can't construct a really long 1, right? If that was a 1 star, then it would eat as many 1s as possible. But since it's just the 1, it's going to be as soon as it sees the 1, it's the first rule it sees. So this kind of comes into play during the assignment that was due a while ago, where if you said you should have like a text field, right? You have all your rules, and you're checking for all these tags, and then like the random tag, and then you have something that just looks for text, right, to return to the parser to print out. If you were to put that first, you'd be in a heap of trouble probably, right? Because it's going to be like, well, this looks like a text file. And so it's going to return a giant token with your entire file in the text to the parser. And the parser's going to be like, this doesn't mean anything to me. This is, a bad input. So you need to be careful about what ordering you give in your Lex file, because precedence matters here. So I'm taking this out so that our y.output's smaller, because I think 9 or 10 states is enough for anyone. Because I don't want to be here until tomorrow.
No, the United States. If 9 states enough for anyone, what do they
Okay. So this is y.output. The beginning should be fairly simple. It should even look familiar, hopefully, because we wrote it. Right? Those are just our grammar rules and an extra one that YAC creates automatically, which is if it has just the S symbol and the end of file or the end of input, it will accept it. It'll say that was a good input. So all along those, we have 7 rules. It's actually might be good to write them. How is seeing the blue on the board by like? Do you? I just realized the blue was a little faint. Projector. Thank you. Ooh. Oh my gosh. It's so powerful. All right. So let's say we have rule 0. Is that big enough? All right, cool. So I'm writing these down because we're going to be using them as we scroll down, and I don't want to be paging up and paging down a bunch. So this is the only rule we didn't write. Once we get down to 1, these are all things that should look really familiar. Someone want to read these to me? Uno. Oh my gosh, what's the pattern here?
3 trace, and then else. Except don't say that.
Don't say what?
That. Just saying that was the last one.
Now I get it. Else, yeah. All right. So I've taken up 2 lines. I hope that you all forgive me one day. What's rule 2?
Uno colon uno 1. Or empty. Uno's actually, the Spanish stuff is actually lowercase, but it doesn't really matter. But just don't change it.
All right. 3. 4 is what? 2?
Oh, it is that way. Never mind. No, you're right. Those 2. Or empty. We'll probably do the pattern.
Nope.
No, then it's trace colon, trace 3, or empty.
I don't believe you. Is there an 8? Good. All right.
Do you have a pipe instead of a colon?
No, I don't.
Sorry, I have really bad eyes.
I know. I forgive you. Okay. So our next section shows which rules contain which tokens, which terminals that come from Lex, right? These are the ones we defined. So in rule 1, there's an else. In rules 1 and 2, we have 1. In rules 1 and 4, we have 2. And in rules 1 and 6, we have 3. And now I regret naming them numbers. I apologize. Is that too confusing, or are we all right?
Hold on a second.
Hmm?
I was just trying. Okay, we're good.
In case you're wondering, these integer values, the 258 and beyond, that's the main reason we need to include the y.tab.h. So it is essentially just pound defined in C type language. I don't know what it's like in Java. I hear we are Java people here. But it's just pound defined else is 258. 259 for 1, 260 for 2, et cetera, et cetera. That way the tokens that Lex returns to the parser and the ones the parser expect have the same value. So these are our non-terminals. The except is a non-terminal that was made by Yak. We didn't write that, but that's only in state 0 on the left. So left-hand side of the rule or the right-hand side of the rule. The S symbol is an 8 on the left, or I'm sorry. The S symbol is on the left in rule 1 and on the right in rule 0. Uno's on the left in those rules, on the right in those rules, right? So we should be able to, you see this and like, yes, that makes sense with what we've written over there. You know, if you're looking at your y dot output and this looks glaringly wrong, like you realize that there's some, you know, your start symbol is in a completely random place, and you'd be like, oh, well, why is it also in on the left for rule 12? So at this point, we shouldn't have any surprises for our grammar, for the most part. Yes?
So, I'm sorry, so what are the numbers in parentheses for?
Those are the, so I think we have end is 1, error 2, else 3, 4, 5, 6, 7, 8, 9. So these are the, like, how many symbols we have, essentially.
It's just continuing.
Yeah. Now you may ask, why doesn't it start at 262? Good question. I got nothing. Just, that's what it does. So, for everyone who was in lecture Wednesday, the idea that this is a state machine with a stack should be familiar, and that will be good, because that's what we're going to do. Yes, it is a push-down automaton, which is a state machine with a stack. So state 0 is always going to be our starting state. Just to quickly look ahead, we can see we have state 1, state 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 states are enough for anyone. So we're going to see what to do when we shift. So we're going to see shifts, and we're going to see reduces, and kind of how to make sense of that. So we're in state 0, right? And at the point when we start in state 0, we assume that the parser hasn't seen any input yet. So the parser stack is completely empty, and it's in state 0. I'd love to be able to draw a stack over here, so we'll see how that goes. If I draw here, does it cut off for you guys? You guys can see this all right? Okay. So we're going to, I want to just run through what our parser is going to do in the event that we give it our shortest possible input. 1, 2, 3, enter. Right? You might be surprised at how often we move around in states, but that's the simplest we can do for now. So we're in state 0. We haven't seen anything. And so we say, OK, we're stuck here in the state. We have nothing to do. We ask the Lex machine, the Flex, the scanner, to send us a token. So the scanner sends us one token, and it happens to be the 1, because it's changed this from the number 1 to the, the token. Yes. So when we see that 1, we shift it onto our stack, and we go to state 1. So if this is our stack down here, it starts out, empty. I think we can say like a $sign is empty. And now it has a 1 on it. And we're going to state 1. If you guys remember, we always push. We have alternating tokens / variables and states. So we're in state 1 now, so I'll say S1. All right, so now we know that we're S1, and we have a 1 on the stack. So we move to S1. And this first line is kind of a helpful little, like, where am I in the grammar? It's kind of your map. So yes, the dot is where you are. So we have seen a 1. So we're right here. We're right after a 1. We expect to see the rest of this. We obviously haven't, because the parser only sees one token at a time. But this is what we're shooting for. So the 1 is always going to be where we are in the current rule that we're trying to use. So in this state, the only thing we can do is reduce to an uno. The way we can do that is that uno can be empty, right? So we can turn this empty piece of the stack into an uno for free. So we're going to do that. And where do we go? State 3. Good. Now, normally, if you remember, when we reduce, which is what we've just done, we pop things off the stack, right? We pop twice as many items off the stack as we have items on the right-hand side of the rule that we're applying. So why did I not pop anything? Yes? 2 times 0 is 0. Good. So we applied this rule, and we popped 0 things off the stack. And so we pop nothing, and then we push uno, and then we push state 3. So now we've gone into state 3. Does that make sense so far? Good. So state 3, we have now gotten to this point where we've seen a 1, we've seen the uno that we pretty much artificially created, and so now we're here. And we're expecting to see a 2 next. Now, you'll notice that there are 2 things we could do in this state, though. This is because we could see another 1 next, in which case we'd want to reapply the uno rule, kind of recurse back up that tree. Or we could see a 2 and we'll kind of move down the line. Ugh. So happy right now. All right. So we can do this. So I want to do this once with a really simple 1, 2, 3, and then we'll see what happens when we break it, when we do an invalid input. But for now, we're going to see a 2, right? Because we're out of tokens as the parser. We ask the scanner for another token. Scanner takes this 2 and turns it into the token 2. Hands it to us. So we see the 2, and what do? We shift it. All right, so we put it on the stack, and then where do we go? State 6. Which is, of course, not on that screen. So state 6, we've now gotten this far. We've seen the 1, we've seen the uno, we've seen the 2. Now I want the dos. The way we get the dos should be familiar now. We're going to apply that epsilon rule, right? So we're going to reduce. We're going to pop 0 things off the stack, and we're going to push the dos, and we're going to move where? State 7. State 7. Who wants to guess what we're going to do in state 7? Same thing again, right? We're going to push a 3 on there. We're going to move to some other state. And then in that state, we're going to probably reduce a trace and move to another state. So we'll put 4 things on here really soon. So state 7, we see the 3. We're going to go to state 9, right? Right, because we've gotten this far. We have to ask the scanner once again for another token. So we take the 3, move to a 3. Where do we go? State 9. We get to state 9, which we can thankfully see. As you can see, our dot has moved even farther, so we're getting closer and closer to the end, which is good. We're going to reduce again using rule 7. So trace, and we move to, dang it. So we're going to go to 10. Okay. So now that we're, yes, keep.
On the stack, should the dos and trace not be there because those were just reduces that we were doing?
They're null.
They are there. So we did reduce. Okay. But the weird thing, so it sounds weird because we reduced from nothing to something. Okay, so we had nothing on the stack, and we did pop that off, but we reduced to something else. So you'll see a more concrete version very, very soon as we finish the grammar. But most times when we reduce, we're going to pop some things on the stack and then push whatever the left-hand side was. And then there'll be a go-to where we'll push that stack or that state on.
Okay.
I saw another hand up right with Keith. I'm crazy. Okay. So in state 10, we could see 3s, because we could see a whole string of 3s at this point, or we see the else, right? So we ask the scanner again, and what do we get? We get else. Right? So what do we do with an else? We shift it, and we go to state 11. I'm going to erase this top part. Everyone hopefully remembers our input string. Huh?
1, 2, 3, new line?
No, that was not right at all. So state 11. Now this is looking good, right? We've seen 1, uno, do, do, 2, dos, 3, trace, else, and now we're here. So we can't do anything really except reduce. So we're going to reduce using rule 1, and this is where it's exciting. So rule 1 is this big long thing, right? So we're going to reduce that. So we're going to pop 1, 2, 3, 4, 5, 6, 7 times 2, 14 things off the stack. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You may be surprised to learn that that is our stack, right? So we've just reduced all of that to the S, right? I would expect there to be a go-to there. So we're back in state 0 now because I failed to draw it before. And I apologize for that. But we should be back in state 0 because we've popped everything. So it should be back at the beginning. So hopefully, if I haven't messed everything up, in state 0 we should see something to do with an S. Aha. So if we have an S, we go to state 2. That is good. So we'll push state 2 onto the stack. That's not a 2. So to clear the confusion that is inevitable, this is our start symbol, and this S is a state. They're very different. Don't confuse them. So we've gone to state 2, which we, again, cannot see. And this is good. So we've seen the S. We expect to see the end of input. So we ask the scanner for another token. And what do we get from the scanner? EOF. We get EOF, essentially, the $end. We say, the scanner says, I'm done. I'm going home. So we get $. We shift the $end. And we go to state 4. And in state 4, what do? We accept. We win. Hooray. All right. So that's how the state machine works. That's how the push-down automata works.
Stack doesn't need to be clear to accept.
Right. So I mean, when we think about like the idea behind the parser, what we want is we want to be back in state 0, and we want an empty stack. Yak, in order to make things easier on itself, has like an actual accept state. So once it gets to the start symbol on the 0, then it makes sure that we get to the end, and that's when it accepts in state 4. It doesn't always have to be state 4, but it's semantically the same because Yak made up this $end, pushed it on, right? I imagine that it could run into some confusion. So if we had, if Yak wanted to say to itself, all right, as soon as I have just the start symbol on the stack and I'm in state 0, I'll call it. We'll say we won. If it was just as simple as that, then maybe Flex has more input to give. But Yak has given up. The parser said, well, now I saw the start symbol. So if we had like 1, 2, 3, 4, granted, you could write like a backend for Yak that would take care of this, that would end here correctly. But the writers felt it easier to do this. And we love them for it because now we don't have to write it in C, which would suck. Okay, so we have 6 minutes. Yes.
There's something interpreting this file and turning it into C code, right?
Yes and no. Something is turning what we originally wrote into C code. It's creating this for our benefit. So it doesn't actually parse this and kind of turn this into anything. It generated this from our code as well. So would you guys rather see an incorrect input really quick or quickly go over conflicts again? A conflict is, right, so the shift reduce or reduce reduce. It's not necessarily an incorrect input. Plenty of correct inputs and correct grammars can have conflicts. Take, for example, okay, I'm going to get rid of all this now. So if we just had, let's say the start symbol is an expression plus an expression, and an expression is an expression plus an expression or an ID, right? It should look pretty familiar, right? Similar thing we did in our calculator. If we just give this to Yak, is it going to say we have conflicts? Does anyone want to guess why?
Is it reduced conflict?
Oh, a reduce conflict?
Right, reduce conflict is supposed to be either one of those symbols.
There's a decent chance that it'll actually give you, you're right, you might be right. The canonical problem here is actually a shift reduce conflict, though. That'll happen if you have, let's say, so here it comes and it goes, all right, so I see E plus E. And it says, well, should I reduce this down to an E, or should I keep shifting and get this plus E, which wouldn't. So it's like, it's essentially going to be like, which am I going to reduce first in the end? Am I going to reduce this piece, or am I going to reduce that piece? Now, with our really simple grammar up here of just pluses, for our really simple grammar here, it doesn't matter, right? Because we have the benefit of knowing that the plus operator is associative. Doesn't matter. But if we had multiplication in here as well, we'd hit some pretty significant problems. So there are two main ways we take care of these. One is by defining precedences, like we did with the calculator. I don't have enough time to like really go over the nitty-gritty of it, but we can. It's still in the examples. We can look back at it. The other option is to make some intermediate symbols, which we've seen in the slides. If you guys remember the grammar that had, instead of just E's, it had like E, T, and F, and T prime and F prime. Is that familiar at all? In case you're wondering, this is expression, term, and factor. If it makes it easier for you. But this way you get to force precedence. I don't have enough time to show you, I guess. But you can make either intermediate like variables and construct your grammar that way. Or you could have defined precedence with the percent token and precedence and left associative, right associative, and whatnot. More often than not, you're going to use a combination of both. Certain rules are going to be better, certain mathematical things are going to be better just defining the precedence up top, and other things you're going to need intermediate symbols. So like a statement, when we get into C++, is kind of complicated. So you may have pieces of statements. So you have like statement piece 1 and statement piece 2 and statement piece 3, and they're connected these ways. So I have 4 hours of office hours. I apologize for the kind of rushed end, but feel free to drop by and we can talk more about this stuff.